Welcome to Learn Mathematics with Moni. Get your books and pen and get ready to learn.
You're welcome to the lesson on Pythagorean theorem. All of these four are right-angled triangles. Just imagine that each angle is turned clockwise, and that is what is happening here. Pick this right angle, I call right angle triangle, I call 1, and rotate it clockwise. It's going to give you these 2, and continue the rotation clockwise. You're going to get the 3. Continue the rotation clockwise, is going to give you this 4. So whether your right angled triangle appears this way, or like this, or like this, once you are able to spot your right angle, which is the square corner angle, then you are certain it is a right angled triangle. And looking at all this right angled triangle, I want to name the angle between B and C. I want to name it alpha, and name the angle between sides A and B beta. So let us consider the rotation. That means I'm going to be having this as my alpha and this as my beta. This is my alpha and this is beta. This is beta and this is alpha. We want to compare the 3 sides of a right-angled triangle. That is the hypotenuse, the opposite, and the adjacent. If you have not watched my video on naming the sides of a right-angled triangle, I advise you go and watch it now, because it is prerequisite to this class. There is a theorem that has compared the 3 sides of a right-angled triangle, and that theorem is called Pythagorean theorem. What does Pythagorean theorem say? Pythagorean theorem states that for every given right-angled triangle, whether your right angle is like 1, 2, 3, or 4, the square of its hypotenuse is equal to the sum of the square of its opposite and the square of its adjacent. That statement is very simple. Let's pick out the key points in that statement. Square of hypotenuse equal to the sum of the square of opposite and the square of adjacent. So let's interpret that. The hypotenuse square equals to opposite square plus the sum of opposite square and adjacent square. And this is what Pythagoras theorem says. So looking at this, my hypotenuse is B. That means B squared equals to, if I'm considering angle alpha, the opposite is A. That is A squared plus, considering angle alpha, the adjacent is C. C squared. This is not depending on the angle you are considering at all. Whether you are considering angle alpha or you are considering angle beta, let us see. If you are considering angle beta, your hypotenuse remains the same, which is B. So B squared equals to the sum of opposites, square of opposite. The opposite of beta is C. That is C squared plus the square of adjacent. The adjacent of angle beta is A. That is plus A squared. So whether it is A squared plus C squared or C squared plus A squared, both of them are correct in this case. So Pythagorean theorem does not have to depend on the angle in consideration at all. Looking at this, we can change the subject of formula. When we are considering the hypotenuse, the Pythagorean theorem goes this way, and it is very correct. What about if it is the A I need to get? Let us quickly do a recap of simplification of algebraic expression. I want to get this plus c square out of this. That means the entire of plus c square is going to the other side. Then on my left hand side, I'm going to be having b square. This plus c square will change to minus c square, and the only thing remaining on my right hand side is going to be a square. And this is also correct. This is also a correct Pythagorean theorem. This is also a very correct Pythagorean theorem, that a square is equals to b square minus c square. Very correct. What about if I'm solving for c? All I have to do is to take this my a square. Of course, you know there is an invisible positive sign in front of this a. Take this a square to the other side, and on your left hand side you're going to have b square. The plus a square will change to minus a square, and on your right hand side you are left with c square. So stating Pythagoras theorem as c square equals to b square minus a square is also correct. They are just pure manipulation of changing the subject of the formula. So this is Pythagorean theorem. When you change the subject of the formula, this is also correct. When you change the subject of the formula, this is also correct for Pythagorean theorem. But this is the basic. Let us solve problems on Pythagorean theorem. This first example says we are given this triangle, this right angle triangle, and the three sides of the right angle triangle are 12, 5, and x, and we need to find the value of x. We are going to make use of Pythagorean theorem to find the value of x here. Pythagorean theorem states that hypotenuse square equals to opposite square plus adjacent square. The hypotenuse here is x, the longer side of the right angled triangle. I have told you that the Pythagorean theorem does not depend on any angle being considered. This can take the position of opposite, this, and it can also take the position of adjacent. The same thing with this. So you can use them interchangeably over here. That means my hypotenuse, which is x square equals to 12 square plus 5 square. S square is going to be equals to 12 square means 12 times 12, and 5 square means 5 times 5. This means we have s square equals to 144 plus 25. 144 plus 25 is going to give us 169. For us to get our x, we have to take the opposite of this power of 2. The opposite of power is root. So I'm taking square root of both hand sides. Taking square root of both hand sides. Then I have the square root of x square equals to the square root of 169. Power of 2 and square root. Square and square root are one and opposite, so they cancel each other out. I am left with x. So x equals to square root of 169 is 13. So that means this hypotenuse that is being sought here is 13. That means this hypotenuse that is being sought here is 13. That's settled. Let's take another example. This is another example under the application of Pythagorean theorem. We are given this right-angled triangle with sides 5, 4, and y, and we need to get the value of y. Yes, we are going to use the statement of the Pythagorean theorem. Pythagorean theorem says that hypotenuse square equals to opposite square plus adjacent square. We can call our y opposite or adjacent depending on our choice. Right now, I want to take y as my adjacent. That means I want to solve for adjacent. Then I will take all of opposite square to the other side. The sign in front of this opposite here is positive. So when it crosses to the other side, it becomes negative. That means I am having hypotenuse square minus opposite square is equals to, this will be the only one remaining on my right hand side, adjacent square. I can rewrite that, putting the right hand side to the left hand side, as adjacent square is equals to hypotenuse square minus opposite square. And this is very correct also as Pythagoras theorem. So let's impute it into the problem we have. I want to call y my adjacent. So I have y square equals to, the hypotenuse is the longest side of the right angle triangle, which is 5 square minus 4 square. In that case, I have y square equals to 25 minus 16. Y square equals to 25 minus 16 is 9. Taking square root of both hand sides to get my y. I have the square root of y square equals to the square root of 9. The square cancels out the square root. I have left with y equals to square root of 9 is 3. That means the y we seek is 3. And that is where I'm stopping the lesson on Pythagorean theorem.
Thank you for learning mathematics with Moni today. Do you know you are free to share my videos with your classmates, your colleagues, your friends, your cousins? Do that right now and be a blessing to them.